We are starting an introduction to matrices. And I'm sure by now you are able to solve as many questions as you can in under trigonometry and also complex numbers. I think we made the whole thing very simple for you to be able to solve as many questions as you can, which I believe should be simple by now. We are doing an introduction to matrices, and matrices are not actually something that I expect you guys to struggle with so much. I expect you to be able to flow perfectly under this particular topic. Now, let's start with the definition of a matrix. A matrix is just a rectangular array of numbers, okay? It's a rectangular array of numbers. And these numbers are the entries or elements of the matrix. The elements are actually enclosed within the brackets. And I'm sure you are able to see these elements inside. There's another element here. There's another one here. These elements are aligned in stations, in two stations actually. The first station, if I was to give an example of AB, CD, EF, the first station is actually called a row. The second station is actually called a column. These are the two stations in which matrices are aligned. Now, these matrices can actually be represented by three things. It could be a number, like this one, which is a 2, then this one, which is a 1. The 2 is standing for the rows. The 1 is standing for the column. If you have a matrix represented like this, you've got the second row, okay? Sorry, it implies that this is actually a 2 by 2 matrix, okay? The first one 2 by 2, the second one also 2 by 2, row by column. Or it can be represented by the letters. Sure, you're able to see your A here. These are letters. I'm sure you're able to see M. Or it can be represented by a basic or a complex function. So, whatsoever can be inside the brackets, it can represent a matrix. It can be a number, it can be a letter, it can be a function. It's very important for you to understand whatever we are going to be doing today. Now, having understood that, it is very important for you to understand how to add a matrix, how to subtract a matrix, and how to multiply a matrix. Because in most of the times, they will ask you to either add the matrix, to subtract a matrix, or to multiply a matrix. Now, there is something that I really would want you to be able to know, which is very important. We have an example where they're saying, given the following matrix, A is this particular matrix which you're able to see, B is the matrix which you're able to see on the other end. Then they are saying find A plus B. Now, it's very interesting that when you're adding matrices, you add them by their respective positions. So for example, they are saying we find A plus B. I'm going to get my matrix A, okay, which is written like that. And then I'm going to add it to matrix B, which is written like that. Now, to add these matrices, you add them by their respective positions. So, this is going to give me, this 4 is going to be added to these 3, right? This one will be added to this 5, these 3 by this figure. You will be adding them by their respective positions. So this is going to be 4 plus minus 3. Then this is going to be 1 plus 5. Then this is going to be 3 plus 1. And the matrix cross. This is going to be 0 plus negative 1. Sorry. 0 plus 5. 0 plus 5. Then this is going to be minus 1 plus 0. This is going to be 2 plus 2. And we expect that the matrix which is going to come out is going to be 4 minus 3, which is going to give us a 1. 1 plus 5 is going to give us a 6. 3 plus 1 is going to give us a 4. 0 plus 5 is going to give us a 5, negative 1, and a 4. This is how you'll be able to add matrices. You use the same concept for everything. How about when it comes to subtraction of matrices? How do we do it? To subtract matrices, we use the same concept. I'm going to get my matrix A. So this is going to be my matrix A. 4, 0, 1. Sorry, this is going to be negative 1. Negative 1, 3, 2. I'm subtracting it from B. The same concept that you've used on addition is what you are going to use even on subtraction. The only difference is going to come in if we have been asked to be able to multiply a matrix. So I'm subtracting, so it's going to be this 4. It will subtract from this guy there. So it's going to be minus 3. Then 1 minus 5. 3 minus 1. We come to 0, 0 minus 5. Then negative 1 minus 0. And 2 minus 2. And the final matrix is going to be like this. Notice that this is a negative and this is a negative. So when they multiply, they give you a positive. And the 3 plus 4 should give you a figure of 7. This is going to give you a negative 4. And this is going to give you a 2. This is going to give us a negative 5, a negative 1, and a 0. And this is how you calculate your final answer. You use the same concept on all the matrices that will be given to you. Thumbs up if you understand the addition of matrices. Thumbs up, thumbs up, thumbs up, thumbs up. Okay, very good. Now, we proceed. I'm sure we have understood how we add and subtract matrices. It should be simple by now. Now, before I take you into the world of multiplication of matrices, I would like you to know how to be able to find the order of a matrix. The order of a matrix will be able to open your eyes so that you are able to know how your matrix is going to be aligned should you multiply. Given that you've been given matrix A, matrix B, matrix C, and matrix D, then they ask you find the orders. Find the order of the following matrices. They've given you these operations. Well, you can write your solution and then you start your operation. The first matrix that we have is matrix A. When you look at matrix A, okay, when you look at matrix A, you always use the concept row by column. Okay, row by column. So what concept do we use? The concept we use is row by column. So how many rows do we have? So for the first one, we have 2, 3, 4, 0, 1, 2. Okay. Then for B, we have 4, 2, 0, 1, 0, negative 1, 3, negative 1, 2, 0, 2, 8. Now, we always use row by column concept. So you start with the first letter. The first one, the first letter or figure they've given you should be, you consider your row. The second one they've given you, consider the column. So let's start. So this is going to be how many rows? 1, 2. So 2 rows. How many columns? 1, 2, 3, 4. So when we multiply AB, we should be able to get a matrix of this order, 2 by 4 matrix. Okay, it's going to be a 2 by 4 matrix. Okay, 2 by 4 matrix. In other words, your matrix is going to have 2 rows and 4 columns. You go to B. So for B, use the same concept. 1, 2, 3. So 3 by, you go to C. Okay, 1, 2. So this is going to be a 3 by 2 matrix. You're going to have 3 rows and 2 columns. Okay, you go to C. C is simply D by multiplying by C. So you go to D. D, how many rows do you have? 1. So it's going to be 1 by, then we go to C. We go to C, right? 1, 2. So this is going to be a 1 by 2 matrix. So you're going to have 1 row, 2 columns. We go to D, right? AC. So let's go to A. It's 1, 2. So it's going to be 2. Okay. AC. Then this is going to be 1, 2. 2 columns. So it's going to be a 2 by 2. Okay. It's going to be a 2 by 2. And we go to DB. DB is going to be row by column, so it's going to be 1, then 1, 2, 3, 4. So this is going to be a 1 by 4 matrix. Hello, do we know how to get the order now? Is it clear on how to get the order? Thumbs up. Are you clear? Okay, we are good. So we shall always be multiplying the rows by the columns. The rows by the columns. Rows by columns. I'm sure you did this also in secondary school. I'm just trying to remind you anyway. This is natural sciences so that everything gets simple. Sorry. We have an example here, and we are going to be using this example to try to see how we are going to perform these operations. Given that A is equal to that, B is equal to that, and C is equal to that matrix, they are saying perform the following indicated matrices, right? So we do solution. I'm going to be a little bit slow so that we don't get confused. Solution. Okay. Now, they're saying given that we perform the following indicated matrices, so what basically we are going to do, we are going to get the first matrix, which is A. They're saying A minus 2B, so you are going to get the first matrix. Let's operate the first one. So the first matrix is 1, negative 2, 3. Then we're going to get 2, 1, 4. Then you get your 2, negative 2, negative 3. Right? Then you say minus. Then you say 2, open bracket. Then you get your B matrix, which is this matrix here. You put it there. So the 2 that is outside is actually multiplying everything that is going to be inside. Okay? Now, don't you consider it as negative 2. First of all, multiply with everything that is inside. Okay? Multiply with everything that is inside. So this is going to be 1 minus 2, 3, 2, 1, 4, 2 minus 2 minus 3, then minus, this 2 is going to multiply whatever is inside the matrix. 2 multiplied by 1, 2. 2 multiplied by 2, 4. 2 multiplied by 3, 6. 2 multiplied by 2, so by negative 2 is going to be negative 4. 2 multiplied by this 2 is going to be positive 4. Then 2 multiplied by this 3 is going to be a positive 6. This 2 multiplied by 5, 10. 2 multiplied by 1 is 2. 2 multiplied by negative 2 is going to be negative 4. Okay? Thumbs up if you understand there. Is it clear? So I've just multiplied the 2 by everything that is outside. Okay? I have multiplied the 2 by everything that is inside the brackets actually. Now, having multiplied, now I can subtract. So to subtract, it's position by position. So this is going to be 1 minus 2. It's going to be negative 1. 2 minus negative 4. Okay, so this is going to be 2 minus negative 4, which is going to give us 6. So this is going to be a 6. We go to this guy here. 2 minus 4, which is going to give us negative 2. We cross the bracket. Okay, then we come in the second row. Negative 2 minus 4 is Messi Jamba in class? Is Messi in class? I shouldn't be reminding people to join class when I announce. When I announce there's going to be class, I'm not supposed to start reminding you there's going to be class. I'm not supposed to beg you. There's going to be class. Okay? When they deal with you on your portal, that's when you realize that I wasn't stupid to be teaching you every day. Okay? So let's be serious with lessons. We go to the second row. It's going to be negative 2 minus 4. So negative 6. One minus 6. We are doing this one. 1 minus 6. It's negative 5. And there, are you understanding? Negative 2 minus 10. This is going to be like a negative 12. And we do this part, the last one. 3 minus 6 is going to be minus 3. 4 minus 2. Yes, please, someone has got a question. Okay, good. Okay, 4 minus 2. This is like a 2. Negative 3 minus negative 4. Negative 3 minus negative 4. This is going to be like minus 3 plus 4, which is giving us positive 1. Is messy in class? So that's the answer. Okay? That's how you are able to calculate the first operation. We go to the second operation, which is this guy here. The second one is actually asking us to just multiply. So we are multiplying A by B. So first of all, let's find the order. 1, 2, 3. So this is going to be a 3 by 1, 2, 3. So we expect that this matrix is going to be a 3 by 3 matrix. 3 by 3, 3 rows, 3 columns. So we're going to get that matrix there. And actually, this is going to be 1, negative 2, then 3, 2, 1, 4. 2, negative 2, minus 3. This is going to be our A matrix. We are multiplying by B. Now, you always multiply the row by the column, right? So each row, each column, each row, each column. So we are going to multiply all these figures by these figures. All these figures by this figure. All this figure by this figure. When we multiply, if we are done with the first column, we go to the second column. So let's do this now. 1 multiplied by 1, it's 1, plus 2 multiplied by 2. Okay, so I multiplied 1 by 1, I've gotten 1. Then I'm going to multiply, because it's a row, always do this. It's remind yourself. It's row by column. So this same 2, I'm going to multiply it by this 2 here. So 2 multiplied by 2 is going to be 4 plus 2 multiplied by 3 is going to be 6, right? Then what you can do, go in the second column, okay? Okay? You go in the second column, which is this one here. Negative 2 multiplied by 1, it's negative 2. 1 multiplied by this 2, it's plus 2. Negative 2 multiplied by negative 6, sorry, negative 2 multiplied by 3, it will give you negative 6. I go to the last one. 3 multiplied by 1, it is going to be 3 plus 4 multiplied by 2 is going to be 8. Negative 3 multiplied by, sorry, where we were in the second, we're in which column? Third column, right? So 3 multiplied by 1 is 3. 4 multiplied by 2 it's 8. Negative 3 multiplied by negative 3 it's going to be minus 9. Okay, we've done the first column. We go to the second column. So the second column, it's going to be the same row again, but we are multiplying by these figures here. Okay, so we do the same thing. We do the same thing. We start 1 multiplied by negative 2 is going to be negative 2 plus 2 multiplied by 3 is going to be 6 plus 2 multiplied by 1 it's going to be 2. Okay, like that. Then we go to the second one. Negative 2 multiplied by negative 2. Okay, we're using these figures now, multiplying by these. So negative 2 multiplied by negative 2 is going to be positive 4 plus 1 multiplied by 3 is going to be 3 plus negative 2 multiplied by positive 1 is going to be minus 2. We go to the last one. So I'm multiplying this by this. 3 multiplied by negative 2 is going to be negative 6 plus 4 multiplied by this 3 it's going to be 12 plus negative 3 multiplied by this 1 it's going to be negative 3. We are done. Okay, for this part. We go to the last one. So the last one, we are multiplying the first one we are multiplying this by that. Okay, it's always a row by column. So let's start. 1 multiplied by 2 is 2 plus 2 multiplied by 5 it's 10. 2 multiplied by negative 2 it's going to be negative 4. We go in the second one, so this now multiplying by that. Negative 2 multiplied by 2 is going to be negative 4 plus 1 multiplied by 5 is going to be 5 plus negative 2 multiplied by negative 2 is going to be positive 4. We go to the last one. 3 multiplied by 3 multiplied by 2 is going to be 6 plus 4 multiplied by 5 is going to be 20. Negative 3 multiplied by negative 2 is going to be positive 6. We can now find the final matrix. Sorry. What is 1 plus 4 it's 5. 5 plus 6, it's 11. We come here. Negative 2 plus 6 is minus 4. Sorry, it's positive 4. Positive 4 plus 2, it is positive 6. 2 plus 10, it's 12. Then 12 minus 4, it's 8. We come here. Negative 2 plus 2, it's going to give you 0. 0 minus 6 is going to give you minus 6. We come here. 4 plus 3, 7. 7 minus 2, it's 5. Minus 4 plus 5, it's 1. 1 plus 4 is going to give you 5. We come here. 3 plus 8, 11. 11 minus 9, it's 2. Negative 6 plus 12, it's positive 6. It's positive 6. Positive 6. Positive 6 minus 3 is positive 3. 6 plus 20, it is 26. 26 plus 6 is 32. So this is going to be our matrix. Okay? Notice our matrix is a 3 by 3 matrix. Thumbs up. Do you understand? Thumbs up, thumbs up, thumbs up. Is it clear? Okay. I'm sure it's now clear on how to find the multiplication of a matrix. You find the order first so that it helps you to be able to find everything. Okay? Friday, is it clear? All right, thank you. Now, we've done this operation. We do the second operation. The second operation, they are saying BA. Now, BA, you are going to do it yourself because you're multiplying B. You start with whatever is in B. You're multiplying it by A. To take us time, I don't want to do that one. So you'll be able to do it yourself. We can do D. Let's try to do D and see if it's going to give us anything normal. Notice that D is an operation. They're saying we have A, open the bracket, then 2B minus 3C. So first of all, I work out whatever is in the brackets. I'm going to get a 2 and open the bracket, then get my matrix B. Like that. And then I can multiply and get the final matrix B. So this is going to be like a 2, then a 4 here, a 6 here. Then this is going to be like minus 4. This is going to be a 6. This is going to be a 2. This is going to be a 4. This is going to be a 10. This is going to be a minus 4. Right. What else can I do about it to make it simple? Let's do this part here. So, this one is for B. Now let's do C. So C is going to be 3. Then I get matrix C, which is 1, 2, 7. Then 2, 0, minus 2, 1, 3, 0. And then this is going to be like C or final. This is going to be like 3, 6, 21. Then this is going to be like a 6, 0, minus 6. 3 multiplied by 1 is going to be 3. 3 multiplied by 3 is going to be a 9. 3 multiplied by 0 is going to be a 0. Then I can operate now whatever was inside. I can operate the function. So the function was I subtract this guy and this guy. Right? So I can subtract them. So I'm going to subtract. minus this guy here. Just look at how beautiful and simple these matrices are. Aren't these free marks? I'm not saying you underrate them. Solve as many as you can. I'll give you all the necessary concepts that you will need. Now, to subtract this, we use the same concept that I gave you. 2 minus 3, it's negative 1. Negative 4 minus 6, it's going to be negative 10. 4 minus 3, it's a positive 1. 4 minus 6, it's a negative 2. 6 minus 0, it's a 6. 10 minus 9, it's a 1. 6 minus 21, 6 minus 21, it's negative 15. 2 minus negative 6, so minus multiplied by minus is positive, so it's going to be 2 plus 6, which is 8. Then minus 4 minus 0, minus 4 minus 0 is going to give us minus 4. So what if we operate what is inside, we are getting this matrix. So now I can now do the final part. Let me just get a new page. Now, the final matrix is where I'm getting the matrix of A, and then I multiply it with whatever I found inside. So let me get my matrix A now. What was the matrix A? Matrix A is 1, negative 2, 3. So 1, negative 2, 3. What else? 2, 1, 4. So it's going to be 2, 1, 4. What else? 2, negative 2, negative 3. 2, negative 2, negative 3. Okay, 2, negative 2, negative 3, yes. So this is the A matrix. Now we are multiplying with whatever we found in the brackets, which is this guy. Okay, so this guy is negative 1, negative 2, negative 15. So negative 1, negative 2, negative 15. Negative 10, 6, 8. Negative 10, 6, 8. 1, 1, negative 4. 1, 1, negative 4. Up to this far, guys, is it clear? Have you understood how I have performed this operation? Now, from there, I know what order is this. It's a 3 by 3. It's a 3 by 3 matrix. So now I can do the same thing that I did. So I'll start row by column. 1 multiplied by 1 multiplied by negative 1, negative 1 plus 2 multiplied by negative 2. So I'm multiplying this by this. Okay, 2 multiplied by negative 2, it's going to be negative 4. 2 multiplied by negative 15, it's going to give us negative 30. Okay, then I go to the next one. The next one, I can draw dotted line. It's the dotted line by this same row. So it's going to be negative 2 multiplied by negative 1, which will give us positive 2, plus 1 multiplied by negative 2, which is going to give us negative 2. The negative 2 multiplied by negative 15, which is going to give us a positive 30. So now I'm now multiplying this part with the first one. Okay, So 3 multiplied by negative 1 is going to be negative 3 plus 4 multiplied by negative 2 is going to give us negative 8. The negative 3 multiplied by negative 15, 3 multiplied by 15 is going to give us 45. I've done the first part. Again, now I'm using this part with the second part. So 1 multiplied by negative 10, it will be negative 10 plus 2 multiplied by 6, it's 12 plus 2 multiplied by 8, it is 16. I go to the next one, which is the dotted line. Negative 2 multiplied by negative 10, I'm using this part now. Negative 2 multiplied by negative 10, it's always a 20, a positive 20. 1 multiplied by 6, it's 6 plus negative 2 multiplied by negative 2 multiplied by 8 is minus 16. So now I go to the dot, to the zigzag. 3 multiplied by negative 10 is negative 30 plus 4 multiplied by 6, 24. Negative 3 multiplied by 8, negative 3 multiplied by 8, okay, so negative 24. So plus negative 24. Okay. Negative 24. Okay. So it's plus negative 24. Okay. We now go to the last one. So it's always the first one, the row by the column. 1 multiplied by 1 is 1 plus 2 multiplied by 1 is 2. 2 multiplied by negative 4 is negative 8. Then we close the bracket. Okay, we go to the next one. Negative 2 multiplied by 1 is minus 2. 1 multiplied by 1 is 1. Negative 2 multiplied by negative 4 is going to be something like a positive 8, correct? 3 multiplied by 1, it's 3 plus 4 multiplied by 1, say 4. Negative 3 multiplied by negative 4, it's a 12. Now we can find the complete matrix. Negative 1 minus 4 minus 30. So it's minus 1 minus 4 minus 30. It's giving us minus 35. Then we go to the second part, which is this part. 2 minus 2 plus 30 is 30. This part minus 3 minus 8 plus 45, 34. Then we come to this part, minus 10 plus 12 plus 16, 18. This part, 20 plus 6, 20 plus 6 minus 16, 10. Come to this part, minus 30 plus 24 minus 24. It's giving us minus 30. Okay, we come to this part, 1 plus 2 minus 8 is minus 5. This part, minus 2 plus 1 plus 8, 7. Come to this part, 3 plus 4 plus 12, 19. And this is the final answer. Okay, that's the final answer. That's the final answer. Okay, thumbs up, guys, if you understand the operations. I think these things are not really anything that is challenging and stuff. Okay, if you understand the concepts. What other operation can we do that is so interesting? Okay, this operation, you are multiplying A by B. Whatever you are going to get, then you add it to the matrix B. Okay? If you can do that one, you're not lazy. Thumbs up. Thumbs up, thumbs up. If you can do that one, thumbs up, thumbs up. Ah, this is a very good class. Very good class. Very good class, actually. Perfect. Because you know that you just have to multiply AB, then add in their respective manner by B. Jessica. Jessica, is it clear? All right, we proceed.
Yes, yes, yes.
Okay. Jessica is now a male. Is who responded?
Hello, voice note, open the voice note.
Yes, yes.
Oh, okay. All right. So we can now do the F. Mm. Okay, let's now do the last one. The last one, I need to do it so that at least we don't have. No, what does it mean? Okay, so the last one is asking us to operate something. They are saying we find BT plus B. When you see this on top, or when you see something like this, this is a transpose of a matrix. That's a transpose of a matrix. So when they say BT, they are saying B transpose. B transpose. So if you've got the original B matrix, which is 1, 2, 3, then minus 2, 3, 1, then 2, 5, minus 2. Then they say B transpose. I want you to see the trick I'm going to use. Flip all the numbers. So you start, I'll use the column rule. Okay? Sorry, you use the rows rule. You've seen this row. I'm going to turn all those figures into columns. So I'll start with the 1. It's going to maintain the position. Then I'll go to this 2. Then I'll go to this 3. Sorry, to that 2. Have you seen? Then I go to this row. I transpose the 2 like that. Then the 3. Then the 5. I go to the last one. 3, 1, minus 2. That's what we call B transpose. Now, this same B transpose, 1, minus 2, then 2, 2, 3, 5, 3, 1, negative 2. Add it to the original B. So this is 1, 2, 3, then negative 2, 3, 1, 2, 5, minus 2. So, final answer, 1 plus 1 is 2. Then 2 plus minus 2 is 0. 3 plus 2 is 5. I cross the bracket. Negative 2 plus 2. So this part is going to be a 0. 3 plus 3, it's a 6. 1 plus 5, it's a 6. 2 plus 3, it's a 5. 5 plus 1, it's a 6. Negative 2 plus negative 2 is like minus 4. Hello, have you seen how simple this operation is? anything difficult there. There's nothing difficult anyway. There's literally nothing difficult there. Okay, I'm sure you've gotten the concept. Just understand these concepts and everything are going to be very, very simple for you guys. Okay, we've done most of the operations anyway. We now go to another part. Okay. Now, we've got two types of important matrices I want you to know, and that is the identity matrix and the transpose matrix. And the transpose matrix, I think I've talked about it already, which makes me really very excited. An identity matrix is a matrix whose first digit is actually a 1 followed by zeros. Okay, that's an identity matrix. A very good example is the first one, which the first figure is a 1. Even here, the first figure is a 1 followed by 0 followed by 0. That is an identity matrix. It's a matrix which has a first figure of 1 followed by zeros. Now, why do we call them identity matrices? We call them identity matrices because they act like 1. They have a behavior like 1. 1 multiplied by 1 million is 1 million. 1 multiplied by B, it's B. 1 multiplied by HC Academy, it's HC Academy. 1 multiplied by whatever you multiply by 1, it returns back. Okay? So, if you are multiplying anything by an identity matrix, just know that you are going to have that matrix. Very good example is where we have this matrix and this matrix. So, this is an identity matrix, right? If we find A multiplying by the identity, we are going to get we are going to get 2, 3, 5, 2. Is Chola in class? Is Chola in class? Okay. All right. So it has got a behavior like 1. Whatever you multiply by an identity matrix should give you that matrix. The same also by 3 matrix, it will still be able to give you that same figure. Okay? To be able to give you that same figure. The transpose of a matrix is what I taught you. So when we say the transpose of A, so you are simply getting whatever is in the rows, make it columns. 1, 3, 6, 8. That's A transpose. Okay, then B transpose. Let's use this symbol. Whatever is in the rows, make it columns. So it's going to be 3, 3, 0, 8. We come to this part. So it's going to be 0, 4, negative 1, 7. We come to this part, which is going to be a 2, 1, 2, then 6. Okay. That is very, very important for you to understand. Okay? That is very important for you to understand. Thumbs up, clear on that part. Okay, very good. We can now go to a different part. I got some questions from your tutorial sheet. This part is a tutorial sheet question. Let me get another one. Can I get another question? Let me get another beautiful question. I can add it there. Okay. So I can call it B. This one is saying given that you have 3, -1, 1, then A, and then there is 1, 0, then 2, 1, and then they are saying this is going to equal to B, -1, 7, 4. Then they say find the values of A and B. Find the values of A and B. Okay, so now we have these interesting questions. We now operate the matrices. So we can operate them here. We can say solution. Okay. So let me see. The first question is saying, let A be this matrix and B be that matrix that we have there. Then they're saying we verify that this part here is actually equal to this. Let's try to verify. Okay? To verify could actually mean that it is actually true, but just show them what they're doing. So the first matrix that we have the first operation, which they're saying A, then you've got the transpose, and the transpose outside, we verify that it is actually equal to AB, and then T transpose. Okay, so now to make this one very simple, actually, guys, we first of all work out whatever is in the brackets. So let's do this one. Okay. By the way, let's do whatever is on the right hand side. So we find A transpose. Whenever you see something like this, they are simply telling you find the transpose twice. Find the transpose twice. So let's do A transpose. So A transpose is going to be, so it's going to be 3, 2, 1, right? And then it's going to be 5, 0, -1, then 0, 1, and 2. This is A transpose. Then they say, this same thing that you have found here, transpose it again. So let's find the transpose of that. So now this is A transpose. So this is going to be, whatever is a row, we now make it column. So it's going to be 3, 5, 0, 2, 0, 1, 1, negative 1, then 2. Now, I want you to notice something. You will notice that what we are getting is actually the same thing here. Henceforth, A transpose of transpose is just you cancelling whatever is there, and it gives you A. And that also implies that A, if they're using this symbol, it's just you cancelling this, and it gives you the same matrix. Thumbs up. Is it clear? You've gotten the concept there? Very good. Okay, so we have our A transpose there. Now we work out whatever is on the other side, the brackets. They are saying that we can now work out this part, AB. So AB, let's get the matrix of A original. Where is it? A original is 3, 5, 0, 2, 0, 1, 1 minus 1, then 2. Now it's let me see what's operation. It's AB inside, so we're actually multiplying it by B. So I want you to practice more 3 by 3 multiplication. If you practice them more, you don't make mistakes, then you're good to go. You can do anything. Okay, now we can do our thing. So it's always row by column. So it's always row by column. So we can start 3 multiplied by 2, it's 6, plus 2 multiplied by 1, it's 2, plus 1 multiplied by 2, it's 2. Right? We come to this side. Same thing. 5 multiplied by 2, it's 10. 0 multiplied by 1, it is plus 0. Negative 1 multiplied by 2, it's minus 2. Then we come to these guys here. 0 multiplied by 2, it is 0, plus 1 multiplied by 1, it's 1. 2 multiplied by 2, it's 4. Then we come to this part here. We will start with the first one. 3 multiplied by negative 3, it's negative 9, plus 2 multiplied by 0, it's 0, plus 1 multiplied by 3, it's 3. Then I come to the dotted. 5 multiplied by negative 3, it's negative 15. 0 multiplied by 0, it's 0. And negative 1 multiplied by 3, it's minus 3. And we come to this part, the zigzag part, by the same thing. 0 multiplied by negative 3, it's 0. 1 multiplied by 0, it's 0. 2 multiplied by 3, it's 6. Yes. Then we come to this last part here. We do the same thing. 3 multiplied by 5, it's 15. Plus 2 multiplied by 0, it is 0, plus 1 multiplied by negative 1 is negative 1. We cross the bracket. Then we do the same thing. 5 multiplied by 5, it's 25. 0 multiplied by 0, it is 0. Negative 1 multiplied by negative 1, it's 1. 0 multiplied, we come to this part. 0 multiplied by 5, it is 0, plus 1 multiplied by 0, it is 0, plus 2 multiplied by negative 1 is negative 2. The final matrix 6 plus 2 is 8, 8 plus 2 is 10. 10 plus 0 minus 2 is 8. 0 plus 1 plus 4 is 5. Negative 9 plus 0 plus 3 it is negative 6. Negative 15 plus 0 plus, sorry, negative 15 minus 3 is like minus 18. 0 plus 0 plus 6 is actually 6. Negative 15 plus 0 minus 1 it's 14. 25 plus 0 plus 1 is 26. Then this is like minus 2. Now, this is what we've gotten. Then the question says, this same AB, transpose it. Okay, transpose it. So we transpose it. So it's going to be 10, neg 6, 14. This is going to be 8, neg 18, then 26. Then this is going to be 5, 6 minus 2. Now the question was saying, verify if this is equal to this. We verified. Are they the same? Are they the same? So henceforth, A T is not equal to AB transpose. Clear? Very good, very good, very good, very good, very good. Very good. We can do another operation. We can do another operation. Next operation. The next operation is actually saying B transpose plus A transpose is equal to A transpose plus B transpose. Okay, let's try to see if it's actually true. So let's find A transpose. A transpose is actually 3, 2, 1, 5, 0, negative 1, 0, 1, 2. Okay, this is A transpose. B transpose, oh my Jesus, this is going to be 2, negative 3, 5. This is going to be 1, 0, 0. This is going to be like 2. Shtenge, Muswala, are you getting what I'm teaching? Are you understanding? Okay. Now, we get B. Is Chitenge in class? Is someone in class? That's too much of the ladies. Someone, are you in class? Okay, let's get A. 3, 2, 1, 5, 0, neg 1, 0, 1, 2. They're saying we prove if it's the same ones. We now start with A. So this is going to be like a 2, 1, 2, minus 3, 0, 3, 5, 0, negative 1. Okay, let's see what we're going to get here. So this is going to be 2 plus 3, 5, 1 plus 5, 6, 2 plus 0, 2, negative 3 plus 2, negative 1. 0 plus 0, 0, 3 plus 1, 4, 5 plus 5, 6, 0 plus negative 1, negative 1, negative 1 plus 2, 1. Let's see, that's what we're going to get. 3 plus 2, 5. Okay, 5 plus 1, it's a 6. 0 plus 2, it's a 2. 2 plus negative 3, negative 1. 0 plus 0, 0. 1 plus 1, 4. 1 multiplied by 5, 6. So 1 plus 5 is 6. Negative 1 plus 0, negative 1. 2 plus negative 1 is positive 1. Okay, so we have actually verified that bt plus at is equal to at plus bt. Clear? Okay, so we've actually verified. So this is exactly how you find these things. The next one, the next one I won't do it, I'll just instruct. They are saying AB transpose is equal to B transpose A transpose. So what you're going to do is this. Get the normal matrices, multiply them. When you multiply them, whatever you're going to find, right, transpose it. Okay? Whatever you're going to find of AB, transpose it. Write it here. Right? Equate it. Find the transpose of B. Write it here. Then multiply it to the transpose of A. You transpose A. Then try to check if whatever is going to be at Y and whatever is going to be this side are going to be the same. Thumbs up if you understand there. Okay, so I'm sure you can do most of the operations. The last operation I'm so interested. That one. Okay, so in order for us to be able to solve the last question, I'm going to take you back to childhood and then I'm going to play you a game. And this game we're going to play is called hide and seek. So the last one is actually asking us to find the determinant of A is equal to 1 over determinant of A. Now, I want to teach you how to find the determinant of a matrix. So, how to find determinant of a matrix. How to find the determinant of a matrix. Look at this. if you have a matrix, let's say A, and that A is A, B, C, D, this is a 2 by 2 matrix. For a 2 by 2 matrix, the determinant is going to be found by just you cross multiplying. So it's going to be A times D minus B times C, right? So if you've got A is equal to 1, 2, 4, 3, then to find the determinant of A, this is going to equal to, you cross multiply for a 2 by 2 matrix. You cross multiply, so this is going to be like 1 multiplied by 3 minus 2 multiplied by 4. So determinant of A is going to equal to 3 minus 8. Determinant of A is going to equal to minus 5. Thumbs up for a 2 by 2 matrix. Now, it's going to be different for a 3 by 3 matrix. Please, for a 3 by 3 matrix, I want to borrow your ears. So I'm going to use an example. A very good example I'll use is the same thing. So they're saying we find the determinant of A. So let me get A. Matrix A is this one. 3, 5, 0, 2, 0, 1, 1, negative 1, then 2. Now, to be able to find the determinant of A, we are going to use what we call the hide and seek concept. Okay? The hide and seek concept is simply a game that you used to play during childhood, where we hide something, then we seek something. We hide something, then we seek something. Let me show you how that game is applies in mathematics under this topic. So, how do you find the determinant, guys? How do you find the determinant? To find the determinant, you do this. You have seen, you're going to take advantage of the first figure. So you're going to factor it out. Then you open the bracket. Now, hide the row in which that first figure is and hide the column in which that first figure is. So let me hide the row and the column. Okay, so let's play some hide and seek. Hide the row where 3 is, hide the column where 3 is, then seek whatever remains. What remains is this, 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 and this. So I'm going to place them there. 0, 1, negative 1, 2. Then we say minus. Again, we do the same thing. This time around, what do? So the way it is, for this one, right? You've seen this part here. It's positive. Let me wrap this. Let me mention. The second part is this one. Okay, the second part is this one. Now, this 2 is positive. So it's going to be the opposite this time around. I'm going to say negative. If this 2 was negative, what was I going to say here? Everyone?
Positive.
Okay. So you do the opposite for the second one. So minus 2. Then I open the bracket. Let's play some hide and seek. So we play hide and seek. The column where 2 is, hide it. So the row where 2 is, hide it. And the column where 2 is, hide it. Get what remains? This remains. This remains. That remains. That remains. So 5, 0, -1, 2 remains. Next, is it going to be minus or plus? Is it going to be minus or plus?
Minus.
Minus. Even if you are a slow learner, at HC Learning Academy, things should be simple for you. This is, I'm trying to make everything simple for like you're a grade 2, so that you don't get confused in your exams or in your tests. So you factor out the 1, because it was positive, you make it negative. Then you open the brackets. Let's do some hide and seek. We close the row where 1 is and the column where 1 is, and then we do what we get whatever remains. So this is going to be 5, 0, 0, 1. Now, when you reach here, what do? You've now taken it into a 2 by 2 matrix. So now you can do the needful. So this is going to be like this. So you're going to get your 3. Then you open the bracket. Then this is going to be 0 multiplied by 2 minus 1 multiplied by -1. Even here. So this is going to be 5 multiplied by 2 minus 0 multiplied by -1 minus 1. Even here you do the same thing. So this is going to be 5 multiplied by 1 minus 0 multiplied by 0. From here, we can do something. So this is going to be 3. 0 multiplied by 2, it's 0. Then minus 1 multiplied by -1 is -1. -1 multiplied by minus, it's a +1. Minus 5 multiplied by 2, it's 10. Then 10 minus -1 is 11. Five multiplied by 1, it's 5. Minus 0 is 5. So this is going to be 3 multiplied by 1, it's 3. 2 multiplied by 11 is 22. -1 multiplied by 5 is -5. Then this is going to be 3 minus 22 minus 5. And you get your 24. Hello, do you understand? Is it clear? It's very clear. Very clear. Even a grade 2, a GCE, a next studying diploma can understand this. Even a doctor who completed school 14 years ago can understand this. So we've now found the determinant of A. That's how you find for a 3 by 3 matrix. I'm not sure. They can't go up to 4, guys. Like what? Okay. Now the question was saying we prove that the determinant of A is equal to 1 over the determinant of A. So we found the determinant of A to be -24. equal to 1 over negative 24. So are they the same? When finding the determinant, we put absolute values, right? So this is 24 is equal to, then this is just the same as minus Jessica, yes? Jessica, yes? You have a question?
Sir, there where you said 5 times 2 minus 0 times 1. I see 0 times negative 1, it's 0. And then you have written 11 there.
Oh, it's, sorry. When you see me start doing this, just know that I'm in my last now, number nak. So this is supposed to be 10, right? 3 minus 20 minus 5. Determinant is always in absolute value. So this is, which is giving us 22. So what's the determinant of A? So our determinant of A is equal to 1 over 22. Guys, is it clear there? You should try to prove with your sources and then see if we got it correct, but that's how you solve your determinant. Okay, so this is how you do it. Do we have any other question there?
Sir,
Yes?
you have said determinant of A is equals to 1 over determinant of A.
It's not me. It's the question.
Oh, all right, sir.
Okay. So now we find the last one. The last one was saying, given that you've been given whatever thing that you have been given there. So let me get it from the equation. So we have been given, pay attention here, 3, negative 1, 1, then A, then 1, 0, 2, then 1. Now, we are able to perform a lot of things using matrices, guys. Remember, I'd mentioned it can be numbers, it can be letters, it can be an equation. So what you're going to do, whenever you have been given something like this, then they say, find A and B. The first thing that you need to do, work out whatever is being given to you. So let's try to multiply this. Okay, it's a 2 by 2 matrix. So it's always a row by column. So, okay. So this is going to be 3 multiplied by 1. It's 3 plus 1 multiplied by 0, 0. Okay? Then we go to this part. Negative 1 multiplied by 1, negative 1 plus a multiplied by 0, it's 0. Okay? Then you go to the next part, which is this guy here. 3 multiplied by 2, it is 6, plus 1 multiplied by 1, it is 1. Negative 1 multiplied by negative 2 is negative 2. A multiplied by 1, it's A. When you reach here, you know what to do? You are going to have 3 plus 0, 3. Negative 1 plus 0, negative 1. 6 plus 1, 7. And then you are going to remain with an equation here. Remember, I said the matrices can include letters, numbers, and equations. This part here corresponds to this. So, already B now sanga mwachawandi ni 3. This part corresponds to this. And remember, it's an equal sign. So, whatever you have this side should equal this. This part now sanga kari negative 1. Chupabere negative 1 hapa. Meaning this part should equal to 4. Mwachawandi. Insamushena ishtobera. Seka mwaiche. I don't joke when it comes to maths. So, use this same concept that I've given you. Now solve whatever things are down there. Go and enjoy your matrices. I've given you almost everything. Simple. And class ends here.